All right, hello everybody. My name is Dr. Sara Arena. I am the Collegiate Associate Professor and Interim Program Chair for our Biomedical Engineering Undergraduate Program. So I am in a room by myself, so I'm going to go ahead and take off my mask so it's a little bit easier to hear me. Ms. Amanda Sandridge will be joining us shortly. She is the Bme Undergraduate Academic Advisor. All right, so my talk today is I'm just going to talk about our biomedical engineering program here, also talk a little bit about our graduate program and a lot of the opportunities that are available to you through our program at Virginia Tech. So first off, one of the questions that you might have is, what exactly is biomedical engineering? So this is where we're applying engineering analysis and design to medical applications with the overall goal of improving quality of life. So some of the pictures that we have up here, for example, are an EKG or ECG, looking at device development in terms of different ways that we can look at and measure biological signs. We also have a contact lens on here because this is an engineering design, or it is a medical device. We have the artificial heart, the Da Vinci. The Da Vinci is a surgical robot that was developed so that a doctor can actually operate, whether it's in the same room as in this picture or say from across the country or across the world on a patient. And then here we have also engineered or tissue engineered skin. The research areas that we have here at Virginia Tech within our Biomedical Engineering and Mechanics department are biomechanics, translational cancer research, biomedical imaging, neuroengineering, cardiovascular engineering, as well as biomaterials, tissue engineering, and regenerative medicine. So by having these expansive research areas, we also have a lot of opportunities for undergraduates to be involved in research within our department. Biomechanics is where we're applying engineering principles to living organisms and biological systems. So an example that we have here is a locomotion lab, or the Granada Biomechanics Lab. They had a lab tour yesterday that I participated in as well. I'm a collaborator within that lab under the PI of Dr. Robin Queen. And so here, this is all about how we measure human movement and use that towards rehabilitation or injury prevention purposes. There's other areas of biomechanics as well, such as impact and injury analysis, looking at blood flow and fluid flow within vasculature, as well as molecular modeling, and also tissue mechanics, so strength of materials. One of the centers that we have here is the Center for Injury Biomechanics that explores a lot of different aspects of impact injury. So an example here that you might have heard of frequently is the Virginia Tech helmet rating system. So this is the Center for Injury Biomechanics has developed a system for rating helmets across football, baseball, bike helmets, and so forth. So I highly suggest checking that out. This is one of the mechanisms that they use for testing those helmets. Within the Center for Injury Biomechanics, there's also a lot of other impacts that they look at, such as blast injury and traumatic brain injury from a blast injury, as well as looking at impacts from car crashes. So there's also a lot of finite element modeling, where they're modeling all the various aspects of, say, internal organs, skeletal structures, and putting them through a simulated crash, as well as correlating that to real crashes as well. We do have a sled, those test sleds for car tests at one of our labs at Virginia Tech. Another area of research is translational cancer research. So when we're talking about translational, we're talking about going from bench in the research setting to bedside, implementing it within patient care. So we have our researchers are leading these transdisciplinary teams that include clinical faculty, clinicians in the local hospitals, as well as down in Wake Forest. And so their ultimate goal is developing and enhancing cancer diagnostics and treatment plans. So one of our faculty members is featured on here, focused ultrasound transducer for using ultrasound, targeted ultrasound to treat a cancer. So this is Dr. Eli Blastovich, as well as we have Dr. Rafael Davalos, who uses electroporation, which is the use of electric fields to be able to selectively target and kill cancer. And so both of these faculty, as well as many others, are involved in doing kind of the basic research and then getting these technologies into clinical trials and into the actual patient setting. We also have biomedical imaging. So this is where we're applying physics principles to be able to image and understand internal tissues and body systems. So for example, here we have X-ray as well as MRI and ultrasound. We have several faculty who are involved in this, as well as functional MRI up at our Fralin Biomedical Institute. We have several faculty who have research labs up at Fralin Biomedical Institute. Cardiovascular engineering, there's a couple of different aspects of cardiovascular engineering, and I'm touching on two kind of the main ones that we have here at Virginia Tech. One of them is understanding the mechanisms for different cardiac or cardiovascular diseases, as well as developing different diagnostic and treatment technologies. So one of these pictures here is from one of our researchers, Dr. Stephen Pulsing, who has been finding these nuanced aspects of the electrical signal that happens within the heart. And so they just recently have published about this new structure that they found that seems to connect heart muscles and help them to beat in unison. And this other picture here is from one of our other labs, Dr. John Chappell, about promoting vascularization. So what we mean by promoting vascularization, it's the forming of blood vessels for either existing tissues or for tissues that are engineered. So those structures that we're trying to create within the lab setting, or for example, 3D printing, how can we promote the vascularization to keep that tissue alive? Another research area that we have is biomaterials and tissue engineering. So this is where we're using polymers, biological mineral cells, growth factors, and others to be able to regenerate or generate tissues and organs. So here we have a wide variety of researchers as well. This purple and aqua picture right here is actually a tissue engineered lymphatic system in an inflamed lymph node. This is the Munson Engineering Lab or Onco Engineering Lab. We also have here a tumor microenvironment. So this is one of the areas of research that's kind of related between translational cancer research and biomaterials and tissue engineering, is being able to engineer microenvironments of tumors so that we're better able to study them and test different types of treatment interventions. And then we also have kind of the more well-known biomaterials aspect side. So for example, biomaterials related for implants and others. So now I'm going to talk about the different options for biomedical engineering here at Virginia Tech. And I will focus on the undergraduate ones because I feel like that is probably what y'all are most interested in. But I will also touch a little bit on the graduate programs. So first off, we have a Bachelor's of Science in Biomedical Engineering. This is our major. We also offer a minor in biomedical engineering for those that are in one of the other majors here at Virginia Tech. We also have a BS/MS accelerated program. So this is where if you qualify for the program, your final year of your bachelor's, you're allowed to count courses towards your master's work. And so your master's typically takes 1 year after that. So it's a total of 5 years for a bachelor's and master's degree. We also offer a master's degree, PhD, as well as a DVM, which is a doctorate of veterinary medicine with a PhD option. Currently, our enrollment for undergraduate Bme majors is 105 students. We currently have 2 cohorts. We started accepting our first cohort in the fall 2019, which I will touch on in a second. We also currently have 165 Bme minors. So these are students who majored in a different major, such as mechanical engineering or electrical and computer engineering, and have added a Bme minor. Our current enrollment in our graduate program is approximately 130 students, with 27 of those being masters and 103 of them being PhD students. Our bachelor's degree was approved by SHEV in 2018, and we were able to take our first cohort of sophomores in the fall 2019. So our first cohort will be graduating next spring with the class of 2022. And this is a picture of our first cohort along with several of our faculty members. So I'll kind of step through the curriculum a little bit. So as you're probably aware, at Virginia Tech, all students come into the College of Engineering under a common year, which means you are in general engineering for your freshman year. At the end of your freshman year is where you apply for your change of major into one of the degree granting programs. So your first year within the BME program would be in your sophomore year. So these are the typical courses that you take. These are the ones we suggest. Again, you might be ahead in some aspects of that, depending upon what amount of credit that you come in with. So typically the first year, you have within your sophomore year, the first year of the BME program, you're taking several math courses, multivariable calculus, DiffEq, and getting into our mechanics courses, statics, dynamics, as well as into computational methods. One of the required courses, one of the required courses with the BMES designator that you start taking in your sophomore year is Intro to Biomedical Engineering. In the junior year is where you start getting into your lab work. So we have a 2-credit cell lab where you're actually in the lab seeding cells and going through all those different processes. This is also a great precursor to help have you ready or gain additional skills for getting into research within the BME department, as well as you're taking your Introduction to Medical Physiology course. We also offer a Bioinstrumentation Lab, where you're learning about the various aspects of instrumentation that we can use or that we use to monitor or treat individuals and or other living organisms. So, for example, you build an ECG or EKG, as well as look at EMG, which is electromyography, measuring muscle activity, plasmography, which is what is used for pulse oximeters. There we go. Cannot think of the word. Another required course in our curriculum is problem solving in BME. So this is where you're starting to gain and put together all the skills that you have learned, particularly related to mathematical modeling of biomedical problems. Senior year, you have Senior Design and Project. This is a year-long project that you're working on in a team towards addressing some need within healthcare. You'll also see that we have a lot of technical electives, particularly in the junior and senior year. So overall, with an undergraduate degree, we have 21 technical elective credits. What this means is these are classes that you get to choose, and we have lists of classes available so that you can specialize your degree to what your particular area of interest is. So for example, if you're interested in biomechanics, you can select your technical electives to be involved in musculoskeletal biomechanics, where you're learning about locomotion and how muscles create movement and how we measure that movement. You can also get into classes where you're looking at strength of materials, so the biological structures and how tendon interacts with bone and all the different tissue properties of that, and the properties of the tissue engineered aspects that we can say. For example, ACL grafts and other things that we use once you tear your ACL, look at all those kinds of strength materials. We also, kind of the specialized areas that you can really tailor your curriculum in. Another example is biomedical devices and imaging. We have a biomedical devices technical elective, as well as many instrumentation electives that will let you kind of specialize and get a more detailed focus on, say, electronic aspects or how devices interact with the body. Also, cell and tissue engineering, we have several courses where you can learn more on that aspect. Biomedical engineering itself is a very broad field, so you can be working, say, at the cellular level all the way up to the full-scale human level. So by having these technical elective credits, this allows you to really focus where you want to. If you elect to do a Bme Minor, the Bme Minor is a total of 18 credits and includes required courses of Intro to Biomedical Engineering and Medical Physiology. There is 6 credits of approved electives, so there's a list that you can choose from to meet that requirement, as well as 6 credits that can be met with BME research and or your senior design project if it is BME related. I'm also going to talk about a few of our undergraduate student organizations. So eNABLE at Virginia Tech. eNABLE is actually a national organization, but you apply for a chapter for your local area. And so we have a chapter of eNABLE at Virginia Tech. And this organization designs and prints 3D printed prosthetics and assistive devices. And these are for amputees in the local area, so New River Valley, as well as the other surrounding areas here. The pictures that we have here are actually an example of one of, or a couple of the devices that they created for a local amputee, a young boy who wanted to be able to throw a baseball, throw a football, be able to catch them. So they're working with that boy and his family to be able to print these devices. Another organization that we have associated with our department is Bioactivity. So this is a student-run biomedical engineering design team that creates medical devices and machinery to address local and global clinical needs. So the example pictures that they have here is where they're building a lift for bariatric patients for EMTs. So this is their initial prototype as well as their CAD drawings and working within the design space to be able to fabricate their prototype. So the other question that we receive a lot is, where can you go with your BME degree? So as I also said, we are having our first cohort graduate next year. So we don't know exactly where our specific students will go because we have not had any graduate yet. But we can look to one of our other programs. We've had the Bme Minor for a long time. So kind of looking to where those students have gone. Typically we see, and we also expect to see, that about a third of our students will go to industry. A third may go to a government lab such as the FDA, and a third expecting to go into higher education, meaning they're going to go into graduate school or clinical school like MD, PA, PT, or other. Some of these companies that we have up here on the slide are examples of where our BME minor students have gone as well. So Boston Scientific, Johnson & Johnson, Cook Medical, GE, there's a lot of biomedical device companies in here, as well as the government and NIH and the FDA. We've had a lot of our students go to, say, automotive companies, Volkswagen, GM, Honda, as well as into consulting. So Exponent is one of the companies that has a lot of BME consulting. And also Cell Inc. is one of the companies that was developed actually and has several of our graduate students who've gone into. That is the company that has developed 3D printing of cells. So one of the other things I'm going to show you, this is a spotlight of one of our first cohort students, Julia Wakefield.
I chose Virginia Tech because when my sister came here, I noticed that she just genuinely fell in love with Virginia Tech, and when I came here, I also fell in love with the love that everyone had for service. I love the arts and crafts, painting, clay works, and I found that the biomedical engineering program was the best way where I could mold my two passions for helping people and using the arts to create things that will change their lives for the better. eNABLE is a club at Virginia Tech where we create 3D printed prosthetics for those in need around the New River Valley area. And currently I am on a project to create a football prosthetic for a little boy who's local to the Blacksburg area. The core of engineering is that its technology is supposed to be used to help people and to enrich others' lives and to bring good change. I feel as though I was really put here to help people, and Virginia Tech is truly helping me towards that goal and fulfill my dream.
For more information, we highly encourage you to look at our website. It's bme.bt.edu. There's various pages on here that go through all the different research we have, all of our faculty, as well as more information about the biomedical engineering minor as well as major. And so for the rest of our time here, I'll go ahead and open it up for a Q&A. I'll also talk a little bit about my area of research. So my area of research is in the biomechanics of human movement. I work with Dr. Robin Queen in the Kevin P. Granado Biomechanics Lab. A lot of my research is looking at, for example, slips, trips, and falls, as well as looking at symmetry in postpartum in postpartum health, so after pregnancy. An additional area that I am looking into is also how asymmetry relates across tasks. So if you tend to do one task asymmetrically, do you do that as well in all other tasks? The question that came in is, will you be limiting the amount of students in Bme for our class? So we have had limited enrollment as we scale up the program. Next year should be our last year with a limited enrollment. That again should be, that would be this year's freshman class. Next year's freshman class should be the last year of limited enrollment. How and when can we apply for the accelerated master's program? So the accelerated master's program is something that you would apply for in the spring semester of your junior year. There is some GPA requirements, and details about that you can find out during your junior year. And then that allows you to plan for what classes that you need to take in your senior year to double count for your bachelor's and master's. And that's actually a common program across all the engineering disciplines, so you can do that in other majors as well. How does the curriculum align with students interested in medical school? So there are additional classes that you do need in order to apply for medical school, such as organic chemistry. The flexibility of our program is it does allow some of those to count as technical elective credits towards your degree. And for the exact timing of the classes of when you should take them, because as you can imagine, organic chemistry is an example of prereq for biochemistry and others. That is something that you can talk with your academic advisor about once you are here and know that is the route that you want to go, and you're able to plan and make sure that you get those courses in when you need them before you have to take the MCATs. When you apply as an incoming freshman, do you apply as a general engineering major, or do you have to apply as a biomedical engineering major? So how Virginia Tech College of Engineering admissions work is everyone does come in as a general engineering major. And then once you have completed your freshman year is when you do your change of major application for whichever your intended degree is. The applications might ask you for your area of interest. This is just so we know, the College of Engineering knows kind of approximate distribution of where our students tend to go. But we know fully well that that might change by the time you actually declare your major. I will also say that I am a 3-time Hokie. I earned my undergraduate degree in engineering, science, and mechanics with a concentration in biomechanics, a master's in biomedical engineering, and a PhD in biomedical engineering, all from Virginia Tech. I also worked at High Point University for several years in the Department of Exercise Science before returning to Virginia Tech. So I am a lifelong Hokie if you have any questions about undergraduate education in general or the Virginia Tech area. Okay, so the question is, how many general engineering students apply for the Bme major at the end of their sophomore year, and how many will be accepted following the interview process? As I stated a few minutes ago, the interview process is something that will only be for when we have limited enrollment, which will be for this upcoming freshman class will be the last class that will be under that limited enrollment. At the end of your freshman year, after that point, the biomedical engineering major will be under the General College of Engineering Enrollment Management System, which is you are guaranteed your choice of major with a GPA of 3.0 and above, and then additional spots are available beyond that based upon faculty numbers and a faculty to student ratio. And I believe the other question was about how many apply for the biomedical engineering major. Currently it is, I think around 100 and 125, but that does vary year to year based upon each class that comes in. So each class is a little different. Do BME students learn CAD through the BME classes, or is there a separate CAD class to take? So CAD is computer-aided design. The program that is right now part of the freshman engineering bundle is Solidworks, and that is something that you do learn in engineering education that first year. You get introduced to the software in your first year. We also do some of that in Intro to Bme, as well as we are offering a certification course, so a SolidWorks certification course through the Bme program. So there are specific Bme applications for SolidWorks, and you end up once you've gone through the course, you would get certification in Solidworks, which is actually something that a lot of companies are very interested and really look for when hiring. All right, again, my name is Dr. Sara Arena. My email is sarena@vt.edu if you would like to email me and ask any questions outside of the webinar. But we appreciate you coming today and look forward to seeing you. Bye.